Next example, find rank and nullity of the matrix. That is, we have to find the, in order to find the rank of the matrix, we have to find the basis for row space or column space. And in order to obtain the nullity of the matrix, we have to obtain the basis for null space of the system Ax is equal to 0. Okay. If you find the rank, then in order to find nullity, we can also use the rank nullity theorem. That is, suppose the rank of the matrix is 2, then we write the rank of A plus nullity of A is equal to number of columns in this matrix. By using this theorem, we can also find the nullity of the matrix. That is, in order to find rank and nullity, we find rank and then use the theorem, or separately we find rank and separately we find nullity. So we will solve this example in different methods. So we have to find first rank of the matrix. So we have to reduce this matrix to, we will find the rank of the matrix by using the method that we will find the basis for row space of the matrix. So we have to reduce this matrix to row echelon form or reduced row echelon form. In order to find the rank of the if you have to find the basis for column space, then we have to reduce the matrix to echelon form, reduce row echelon form. We just reduce the matrix to either echelon form, row echelon form, or reduce row echelon form. So we have to reduce this 3 minus 1 and 2 to 0. So operation are R2 minus 3R1, R3 plus R1, and R2 minus 2R1. So after this transformation, we have this matrix. Then we have to reduce this minus 14 to 1. So minus 1 by 14, R2 is the application. We have 1. And then after that step, we apply these two, that R3 minus 4 R2 and R4 plus 5 R2. So by using this 1, first reduce this equal to 1. So apply this operation, then apply these two operations. We have this matrix. And this is in echelon form. We have to reduce row echelon form. Then this column number 1, column number 2 contains leading 1. These two columns contains leading 1. So we have to reduce this 4 to 0 in order to reduce this matrix to reduced row echelon form. So what is the reduced row echelon form? This is the echelon form. In reduced row echelon form, the elements that contains the columns that contains leading 1, in that columns, the remaining element other than the G1 are 0. So we have to reduce this to 0. So R1 minus 4 R2. So we have this matrix. And this is the reduced row echelon form. So there are two non-zero rows in the echelon form, a row echelon form or reduced row echelon form. And therefore the rank of the matrix is 2. Because what is the basis of the matrix? Or basis for row space of the matrix? So form this row as a one element and this row as the second element, and the set containing these two elements is the basis for row space of the matrix A. Row space of rows. This is the basis for row space of the matrix A, and therefore rank of A is 2. Okay. So in order to find the basis for null space of the matrix, we have to reduce this matrix to echelon form, and then we have to write the rewrite the equations. So rewrite the equations from the reduced to echelon form or row echelon form. Either reduce the matrix to row echelon form and then rewrite the equation, or reduce the matrix to reduce row echelon form and then rewrite the equation. So from this we have x1 plus x3 plus 2 x4 plus x5 is equal to 0. So this is the augmented matrix actually, and then x2 plus x3 plus x4 plus x5 plus 2x5 is equal to 0. So there are two equations and three unknowns. So assign three unknowns, and that are the, we have to assign three unknowns that are the parameters. So we assume that x3 is t, x4 as s, and x5 as t, and therefore from equation 1 we have x1, from equation 2 we have x2. By using these two formula we have this. So this is the solution of the system. So x1 and x2 are the leading variables. There are two leading variables and three parameters, because we have to assign three variables, means there are three parameters, and we assume that three parameters we have x1 and x2, that is there are two leading variables, and this number of parameters is nothing but the nullity of the matrix. So nullity of the matrix is 3, and the leading variables are 2, and therefore rank of is 2. Or we can find by using this. Write this solution as in the form of matrix, and then write the coefficient of R, coefficients of plus S, T. And what are the coefficient of R? Minus 1, minus 1, 0, 0, 0. Minus 1, minus 1, 0, 0, 0. So this is x3 is R, st. So right here R dot t, x3 is R, x4 is S, x5 is T. So minus 1, 1, 1, 0. Then S coefficient of S minus 2, minus 1, 0, 1, 0. And then coefficient of T minus 1, minus 2, 0. Here is R dot T, 0, 1. So RST belongs to R, any real number, and therefore this set, right? This as the first vector, this as the second vector, and these three vectors, or the set of these three vectors, is a basis for a solution space or null space of the matrix A. Solution space of the system X is equal to 0, and null space of the matrix A. And so nullity of A is 3. And nullity of A is 3, and rank of A is 2. So their addition is the number of columns in the matrix is equal to 5. So if the question is verify the rank nullity theorem for this matrix is the question, then we have to find the rank and nullity independently. That is, find rank and then by using the basis for null space, we will find nullity. And in our example, the given matrix is of order 4 by 5. So the number of columns are 5, and we observe that rank of A plus nullity of A is 2 plus 3 is equal to 5. That is number of columns of A, and therefore the rank nullity theorem is verified. We will say that rank nullity theorem is verified. So this is the rank of A, and rank of A is number of leading variables, and nullity of A is the number of parameters. So find the number of parameters in the general solution of Ax is equal to 0. That is, we have to find the number of parameters, means we have to find the nullity of A, and the rank of A is 2. So use the theorem that rank of A plus nullity of A is equal to number of columns, that is 6. And so nullity of A is n minus rank of A, that is 6 minus 2, that is 4. There are 4 number of parameters. Number of parameters means nullity of A is 4, and therefore in the system X is equal to 0, there are 4 parameters. So in this matrix, there are 5 columns, and so rank of A plus nullity of A is 5, and this is consistent with the example 1, where we observe that rank of A is 2, rank of nullity of A is 3. For this is the repetition of this example 1, 4, 5, 6, 9. So we will observe that rank of the matrix A and plus nullity of A is 5, that is number of variables. If find nullity of the matrix A if A is 4 by 6 and rank of A is 3. So rank of A is given. So use the theorem rank of A plus nullity of A is equal to number of columns, that is 6. This A is of order 4 by 6 means there are 6 columns. So nullity of A is what? Now 6 minus rank of A, that is 6 minus 3, that is 3. So these are some exercises on this example. Find basis for null space of A. So these are the matrices. We have to find the null space. In this second example, we have to find the basis for row space by reducing the matrix to row echelon form. Then find basis for column space. Example number 3. Or these are the matrices. Same work out the same problems for column space. Then find basis for row space of A entirely. Don't write this example number 4. Find basis subspace spanned by the given 3 vector. That is, write the matrix A as its columns, its rows are these 3 elements, and then find the basis for row space of that matrix. So in this example number C, we have to write the matrix contains how many rows? 1, 2, 3, 4, 5, 6 rows. So write the matrix that contains 6 rows as this, and then we find the we will find the basis for row space of that matrix, and that is the basis for subspace spanned by these 6 vectors. Okay, So rank and nullity, again find the rank and nullity and verify the values obtained satisfying the formula of dimension theorem. That is, independently we have to find rank and nullity. That is, find the, in order to find rank, we will find the dimension of row space or column space. So, and in order to find nullity, find the basis for null space of the matrix. So these are the examples. Null space. For the answer are given when for these matrices number A, B, and D. Here it is not C, B. Here write D. So for these matrices, the null space is singleton 0, 0, 0. So when if the null space is singleton 0, 0, 0, when this is null space, if for D example it is null space is 0, 0, 0, and therefore actually this is the basis for. So what is the basis for if the null space, if all the values of x1, x2, x3 are 0? So if you observe the previous example, this example, okay. So this is the matrix, and how we can find its nullity by reducing the matrix to row echelon form or reduced row echelon form, rewrite the equation, and then find the values of x1, x2, x3. So if you assign three unknowns, then nullity of A is 3. Okay, nullity of A is 3. But if you assign two unknowns, in some example, if you assign two unknowns, then nullity of A is 2. If you assign one unknown, then nullity of A is 1. But if after rewriting the equation, we have the equations is equal to number of unknowns. So in this example, what happened? There are two equations and three unknowns. So 3 minus 2 is equal to 5 minus, there are 5 unknowns and two equations, and so difference is 5 minus 2, that is 3. So we have to assign 3 unknowns, and therefore the nullity of A is 3. So if you assign 2 unknowns, then nullity is 2. If you assign 1 unknown, then nullity is nullity of that matrix is 1. And if you assign no variable, that is, if we, after rewriting the equation, we have the number of equations is equal to number of unknowns, then in that case the nullity of the matrix is that matrix is 0. So we will solve that type example. That is, this is the example of this type A, B, and D. So we will solve this D example. So nullity of this matrix A is 0 because we have all the values of x1, x2, x3 as 0. No need to verify the, and so null space of that matrix contains only one element, 0, 0, 0, 0, single element vector space. Okay, only 0 vector is there. So these are the answers of the problem. So we will solve that problem. So solution of that D, null space of A is equal to solution space of the system. So the solution space of the system, answer number D. So this is the matrix. This is the matrix A. What is that? 1 minus 3, 2, 2, 1. So we have to find the basis for null space of this matrix A. So null space of A is equal to solution space of the system. System X is equal to 0. And what is that system? X1 minus 3x2 plus 2x3 plus 2x4 plus x5 is equal to 0 is the first equation. So observe here. Plus, okay. This is example number D. Solution space of the system x1 plus 3x2 plus x4 yes, x1 plus 3 x2 x4 1301 1301. So this is the answer of this problem. Yes, 1301, answer of this problem. So this is the matrix, and we have to find the null space of this matrix, that is, or the basis for null space of this matrix. So write this matrix, from this matrix, the system X is equal to 0. So what is it? X1 plus 3 x2 plus x4 is equal to 0 is the first equation. Then x1 plus 4x2 plus 2x3 is equal to 0 is the second equation, minus 2x2 minus 2x3 minus x4 is equal to 0. Then 2x2 minus 4x 2x1 minus 4x2 plus x3 plus x4 is equal to 0. Last equation is x1 minus 2x2 minus x3 plus x4 is equal to 0. So that is the equation. We have these three equations. Okay. So null space of the matrix is equal to solution space of the system X is equal to, that is solution space of the system this. So from that matrix we will find the system, and now we have to find the solution of this system. So augmented matrix is this. So either consider augmented matrix or coefficient matrix. Don't write this last 0 0 0 0 column, or write the 0 0 0 column. So combination of A and B is the augmented matrix. And now we have to reduce this matrix to echelon form. So here is 1. So we have to reduce this 4 element to 0. Already here is 0. So R2 minus R1, R3 minus R4 minus 2R1, and R5 minus 2 minus R1, R5 minus R1. So after this we have all these 0 and the remaining elements are also changed. Then we have to reduce this 1 is there. So we have to reduce this minus 2, minus 10 and minus 5 as 0. So R3 plus 2 R2, R4 plus 10 R2, and R5 plus 5 R2. And therefore we have this matrix. We have 0 at this place. We have to reduce this 2 element to 1. So if you multiply the third row by 1/2, then we have 1. But here we have minus 3 by 2. And in order to avoid this fractional number, we have to reduce this element to 1. So first multiply by 10, we have 20 at this place. So minus 30 at this place. And then R4 minus R3. So we have the 1 at this change in R4 row. So 1, 18, 0. And then interchange the row, third row and fourth row, we have 1. So after 1, 2 and 3 step, we have 1. But by using this transformation, we avoid the fractional numbers. Or in one step, we can obtain here 1 by using the operation 1 by 3 R3. We have 1 here, but we have the fractional number, and if the fractional number is there, then further calculation becomes somewhat lengthy or tough. So as possible, avoid the fractional numbers while reducing the matrix to row echelon form. So avoid the fractional number as far as possible. If it is not possible, then we can calculate the addition and subtraction of fractional numbers easily. So either operate 1 by apply 1 by R3 as an application transformation, or by using these 3 operation we have 1. Now we have to reduce this 20 and 9 to 0. So we apply this R4 minus 20 R3, R5 minus 9 R3. We have this. Now we have to reduce this minus 390 as 1. So minus 1 by 390 R4 is the application. We have 1. Now we have to reduce this minus 167 as 0. So we have 0 by using this operation, R5 plus 167 R4, and then we have 0. And this is row echelon form, or just say echelon form. This is not reduced row echelon form. This is a row echelon form or echelon form. So, and rewrite the equation. So what do we have? The first equation, x1 plus 3x2 plus x4 is equal to 0. Then x2 plus 2x3 plus minus x4 is equal to 0. The third equation, x3 plus 18x4 is equal to 0. And the last equation, x4 is equal to 0. So if we substitute x4 is equal to 0 in above equation, then we have x3 is 0. And if we substitute x3 and x4 as 0 in above equation, we have x2 is equal to 0. And if we substitute x2 and x4 as 0, then we have x1 is 0. So by using back substitution, we have x4 is 0, x3 is 0, x2 is 0, x1 is 0. So no need to assign the here variables, because there are 4 variables, and after rewriting equation, we have the 4 equations. So after rewriting equations from row echelon form, we have 4 equations, and there are 4 unknowns. So no need to assign the variable. And it means if we assign 1 variable, then the nullity of the matrix is 1. If we assign 2 variables, then nullity of the matrix is 2. If we assign 3 variables, then nullity of the matrix is 3. But here no need to assign variables, that is 0 variables are assigned and therefore the nullity of the matrix is 0. Nullity of A is 0. And what is null space of A or solution space of A? That contains only singleton 0 element. It's the singleton element, contains only 0 vector, that right in curly bracket 0 0 0. It is not basis. It is not basis for null space. It is a itself null space that contains 0 0 0. What is the basis for null space of A? Is the empty set, right? Phi or singleton 0. This is the basis for null space of the matrix. And what is the nullity of A? Is 0. That is dimension of null space of A is 0, and therefore nullity of A is 0. That is, this is the 0 space, contains only one vector 0. So this is this dimension basis for this vector space is empty set, because no, and therefore nullity of A is nullity of A is 0. So this is somewhat somehow a different example other than the remaining examples. So if in order to find the basis for null space or the nullity of the matrix, we have to find the solution space. But if after rewriting the equation from row echelon form, if we assign one variable, then the nullity of the matrix is 1. If you assign two variable, then nullity is 2. But when we assign variables, if after rewriting the equations from echelon form, if the number of equations and number of unknowns are different, that is, if the difference is 1, then we assign 1 variable. The difference is 2, then assign 2 variable. If difference is 3, then assign 3 variable. But if the difference is 0, then we have to assign 0 variable, and in that case the rank is 0. So this is the example. If we observe the previous examples, so some example of rank nullity. So if we observe these examples, yeah, this is the example. So this is the matrix, and what is the nullity of this matrix? So we reduce the matrix to echelon form, and after rewriting, we have 2 equations and 5 unknowns. So we have to assign 3 unknown, and that's why the basis for the null space of that matrix contains 3 vectors, and therefore nullity of the matrix is 3. If we assign 3 variables, then nullity is 3. When we assign variables, if the number of equations and the number of unknowns are different. So these are some examples for homework. The answers of some examples is given. So solve all these examples. We have to find the rank and nullity of these matrices. So null examples, answer of some examples are given. So this is the examples, answers of some examples. So this is also the another examples. Find the row space, null space, basis and dimension of row space, null space. So the space spanned by these, that is, we have to form the matrix whose rows are these vectors. So solve all these examples, solutions are given. So this is the solved example. In case if you have to solution all are equal to 0, all variables are, there is no need to assign variables, then in that case we write the null space as singleton 0 0 0 vector, and right in that case write nullity of the matrix is 0. So this is about the null space, row space, column space, their dimension, basis, rank of the matrix, nullity of the matrix. So we will stop now here. The vector space topic is over. Now we will see the last topic, that linear transformation. The last topic of this paper, linear transformation, in the next lecture. So we will see the definition and examples of linear transformation in the next lecture.